All right, hello everyone. Welcome to Groundwater Talk Live. We have a real treat today. We have Michael Schnieders from Water Systems Engineering in Ottawa, Kansas. They are the preeminent lab and consulting outfit in the entire United States as far as looking at chemical and microbiological diagnostics on water wells. We use them a lot. I can't recommend them highly enough, and we're going to dive into what they do and some of the factors in well plugging, especially chemical and microbiological, that a lot of people don't understand. There's a couple publications that they put out. Probably the most recent one from Mr. Schnieders is the operational stage of the well. And let me back that up here a little bit. This is available from the National Groundwater Association. It's not a real thick book, but it is packed with information, no fluff in there. And then, of course, Mike's dad, John Schnieders, is this was his book here from John. And there's a ton of information in here as well as far as well rehab goes. So it's awesome stuff. And we're going to dive into a little bit of this talking with Mike. Let me bring him on here. And there we go. Good morning.
Good morning. Thanks for having me.
Oh, thanks for coming on. It is quite an honor. The breadth of your knowledge in this industry, I guess, or this niche part of the water industry is so important because the tools you offer from Water Systems Engineering really help us keep the wells going at optimal, capacity, and just doing the diagnostics is so important. And there's so many things that people don't understand. So, can you give us a little background on, how you got into this business? I know your dad got it going, and you're, I know your dad is kind of semi-retired, as much as that ever happens. But a little background, and then we'll kind of dive into things from there. So.
Sure thing. And it's more of a driller story than you hear from consultants. But I literally grew up in the business. My dad started the company as an investigative lab that assisted with industrial water issues. And that's boilers, cooling towers, process waters used in everything from heavy equipment manufacturing, energy development, canning, so forth. He started getting questions, kind of as I'm sure, as we've all experienced. Well, what about this? What about that? And started to get brought more into water supply and was working predominantly in surface water, and then started to get some questions about groundwater. Around that time, I was completing my bachelor degree in geology. I started helping out here and there, and that worked nicely because as I went into grad school, I needed some additional help in geochemistry and got that from my dad, and I supplied him some additional help in geology. So it was a nice fit. Then it was kind of one of those things. Well, why don't you help out for 6 months, and we'll see where we go, see what other opportunities are there for you. And next thing I know, 20 plus years have passed, and I'm still helping out. But yeah, like you said, my dad, his background was chemistry and microbiology, started the company and almost, I would say, worked full time till about 78. Started to take a little time off, maybe retired in the sense he's not in the lab every week, but we still rely on him. Both myself and my staff, we've got a great resource there. He's seen a lot, he's done a lot, and as most of the individuals in our water industry know, it's good to have someone that you can reach out to in your network, and they may have seen something or experienced something that you haven't yet, and so been in their ear. In fact, I've got to go over and talk about a few things with my dad this afternoon. So use some of that knowledge still.
Tap into that knowledge base. Yeah. I mean, that's hard to, that is hard to duplicate. You just can't duplicate that. So, you know.
Agreed.
So you do, and let me switch to. We'll give you more of the spotlight here. Um, so, so you do thousands of wells across the country, and what are some of the trends you see? You're looking at the chemistry and the microbiology, and what are some of the trends you actually see? As far as well plugging, and then we'll kind of dive in later to talk about how the chemistry actually affects the well rehab, and how we mix our chemicals and how much we use, but just some of the plugging and the chemical and microbiological factors you kind of see overall. And I know there's some regional issues, and it could, some of it's related to geology and stuff like that. But just some of the general trends you see, so people get an understanding of what you're doing and some of the problems that are out there.
Definitely. And, reel me in if I start taking several days and explaining. Um, we're blessed that we do get samples from all over, and I'm always amazed to look down the list of things in the lab and where they pop out of. California, New Jersey, Nova Scotia, Florida, and so forth. A little bit of everywhere, predominantly North America, but I would say that there always is a mix. You may have calcium scale that dominates, but the biology has played a role in some way, shape, or form. You may see iron bacteria, is present, but the corrosivity of the water, influence from the chemistry, has maybe spurred that on a little bit. So, for years, the industry fixated on coliforms, brought about by the incident in Walkerton, Canada, and the total coliform rule and its revisions over the years. And that's good, don't get me wrong, but there's a lot more going on. But by looking at that as an industry, then we started to uncover some of these other things that go on. I would say, two things that really kind of drive. One is core well design, and did we understand the environment when we designed that well? And that's part of, do you have sufficient flow so you don't have stagnation? Are you using the right materials so you're not generating more iron or, more pockets for problems to develop? And then the second thing is how we use that well. So the design and construction, but then, the use. It's probably manifests itself in the residential well, and the hunting cabin or the vacation spot at the lake that has that well that get used 5 or 6 times throughout the year. Those people probably see it, fast and the most upfront because they're intimate to that. But municipalities see it. We'll cycle part of the well field off for the winter because the demand is down. And next thing you know, they've got an anaerobic bacteria problem. We also see it in the West, and I would say that's probably Mississippi West, Mississippi River West, in conservation efforts, where we try to idle wells or limit their production to slow the depletion of an aquifer or to enhance, the rebound in an area. While that is got a good intent, if you've been operating that well at 1200 GPM and now you shut it off for 6 months, you're going to have a problem. And that problem is going to manifest itself first in biological, but it's going to be chemical and mechanical too. And I think sometimes, our best efforts at conservation, we end up wasting more more water, because we have to go in and flush that well and then rehabilitate it and disinfect it. And, were our intentions good? Were our results what we needed? But those are two big issues, designing and constructing it appropriate to what you know about the aquifer and what you know about the use, and then how do we use that? And then there's everything in between. Not to rule out even bad luck, whether that's surface influence or a structural geological tectonic shift there changing things, or just aquifer changing over time.
Yeah, I'll second the bad luck thing as a guy that does well location studies. Sometimes there's just no water, so it's just kind of like that. We don't have 100% knowledge on what's going on under the ground. So, and that's part of why your services are so valuable, is because you get, in a nutshell, one report, really, a lot of information that's some people look at that and say it's a little hard to digest, but you go through and explain it all and that type of thing. And so my next question is really, can you explain or just, give us a rundown on your process, from the samples to what you do in the lab to the report, and kind of the rationale. I know you take two samples and what those are, and what the rationale is for the timing on those samples, and then what you do on the lab, and then how you report things to folks and the recommendations you make. So
Certainly. So, it usually starts out with a call. We've got a such and such issue, and we implore the client or the new client, an existing client, so forth, give us a little bit of background. And sometimes that's some file cabinet digging, contacting a few different, an engineer or a driller or whomever. So while they're doing that, we get the sample collection process started and submitted. Ideally, you're right, we would like to get two samples. And one of those is when the well is actively pumping. So we see what's coming into the well from the aquifer, and that gives us an idea of background conditions. Is the water hard? Does it have an iron issue? Are there nutrients coming into the well from the aquifer that are going to stimulate bacterial growth? And also gives us an insight of what's native from a biological standpoint to that aquifer system. And then we want a second sample, which we refer to as the casing sample, when the well has been placed offline. Typically no more than 24 to 36 hours total, but we want to see what occurs when that inflow stops. Kind of what does the well do with that supply that we saw in the aquifer sample? And that's where you'll see a lot of chemical congestion. If active corrosion is occurring, whether it's chemical or biological or physical in nature, you'll see that iron generated, and we can look at the iron in the different states. And also the microbiology. That's where you see that use of the nutrients, and we can look at growth cycles of the native bacteria and see who is the dominant species and what do we know about that species. Then also, we look from in both samples on the physical side, look at it under the microscope. What has congested? What do we have insect parts? Do we have fungus or mold, which would suggest we're getting some influence from the surface? Do we have algae? So we are getting direct sunlight influence there in some way, shape, or form. What's occurring on the sediment side? So do we have fractured silica that would suggest we got some turbulent flow? Do we have silts and clays, and do those match up to what we know about the lithology? So those two samples really tell us a lot. So we have a procedure we advise the client, and ideally, we'll get, as I mentioned, an active pumping and a static. And sometimes those are luxuries. The pump has been out of the hole, or the well hasn't been operated for 3 years. And so we make some adjustments, and there's a lot of CYA type of things, This is a worst case scenario because of the way it was collected, but samples will arrive. And the first thing we do is we look at some core stability parameters. So pH, oxidation reduction potential, the hardness levels, the conductivity levels. And at the same time, we're initiating the start of the biology. So we'll run a population count via ATP as soon as the sample is arrived and is stabilized, and then also initiate the growth plates and things like your total coliform test, your sulfate reducing bacteria test, your anaerobic tests that take time, and you want to inoculate them with a fresh sample. And so the samples, we advocate a full 1 liter sample, so we have enough both for the chemistry and biology, but then also for any surprises. So sample is quadded and separated for the different tests, and then we put the remainder in a stabilized refrigerator to if we have to go back and look at anything. So, an example there is if we find evidence of polymers, then we'll go back and run some additional testing to confirm the presence of either phosphate or aluminum-based polymers in the sample. And that could be from backflow of a distribution line or residual drilling fluids or previous treatment methods. But the chemical and the biological testing progress. We will also pull that sample and centrifuge it down and look at it microscopically for some of those physical evidence of either the chemical, the biological, or the sediment influence there. Then we'll sit down as a group, and at least once a week, the lab techs and the consultants are sitting down together and discussing the oddities. With looking at over 1,000 wells a year, you get some boring ones. Unfortunately, people don't come to us with the boring ones. So it's the challenges.
Yeah.
And, that's a good thing because it keeps it interesting. But we'll talk about, are we going to have to run a dilution? For example, we got a sample in from a Western state here this week where conductivity was at 15,000. And so, it had a whole different makeup. And so, we got to talk about some dilutions. We got to talk about, what's driving it? Is that a saltwater influence? Is it a mineralized situation? And so, we talk about some of the changes, and, I threw out a couple additional tests I wanted to do because that was so far outside the norm, for potable wells, which is typically what we look at. It also gives us the chance to put some hands on it as a consultant. So, we'll look at the sample container. We'll get a chance to look at it under the microscope. And now that starts the process from a consultant standpoint. We start to digest some of this material. Oftentimes I'll go back and look at the data sheet on the sample, how and when was it collected? What's the story of the well? Even if it is complete, sometimes that will initiate communication to the client. Hey, what more can you tell me? Are you experiencing these types of problems, even though you said it was a taste and odor issue? Start to develop that analytical process there, mental as the results are coming in, and start to look at putting it into how do we make this report more palatable. And that's one thing we really try to do differently. I relate it to when I go to the doctor and I have to get blood work for an annual physical. I can look at these numbers, and what may look scary is actually a good number, and what seems like a good number is actually a scary one. Until that doctor hopefully puts it in context for me, or I get home and I can Google, which you don't want to do that on the medical side of things. On the water chemistry, we try and give our clients, hey, this is normal for a well. This is normal for your region. Or the behavior between the two samples, while the values are normal, that difference of 30% is not. And how does that tie in? Now, I will say, and this was true before COVID, but it certainly is after, the biology always seems very scary because, whether it's, whether we're a drinking water customer or we're in the water industry, we still like to believe our water is sterile. And it's coming out of the ground, it's cold, it's crisp, it's clear, and it doesn't smell like rotten eggs, it's good. And I'm not saying it isn't, but there's a lot in there just naturally. We got it on our arms and hands, despite all the hand sanitizer. It's just part of living here on Earth. And so we try and take the fear out of the microbiology. What's normal range for a drinking water well? What's a good or bad bacteria, and how does that interact with the chemistry?
I
And
think a lot of people don't understand that the bacteria is there, and there's a fair amount of it there. You can't just sterilize your well; it's not going to happen. Yeah.
very true. And I find myself repeating that at least once a week, if not more. We're never going to sterilize it. It's about managing, that population and keeping it within, our guidelines there. And all too often people run to failure. So you're not going to sterilize it. You can dump all the chlorine in the world. They'll be right back tomorrow.
Yeah. So, okay. So now you've kind of done the analysis, and then now you're writing up recommendations. Your recommendation, you usually report kind of what you see and generally in explainable terms, but then you also move on to recommendations for well rehabilitation and that type of thing. And I think you kind of cover some of that stuff in your book, but generally, how do you progress from the results to recommendations?
That's a good question. And it's, with the report, I look at it this way. It may be going to a driller, licensed groundwater professional. It may be going to a professional engineer, but not everybody has the benefit of the knowledge that my team and I have. And so we try and make it very palatable, try and put in those ranges I mentioned, whether they're, a safe drinking water regulation range or just a normal operating range or something that we track in-house. And so the first thing I'll do, and I love the benefit of having two screens, I'll pop it up. I'll have my data on one side and my notepad on the other, and start to go through, what's normal for a well and what's normal for that region. And, with an eye at the location and the depth of the well. I like to start out with just the straight up observations. How did the sample arrive? Was there some discoloration? Was there some odor? What is the core water chemistry telling us? And then I start to move into the transition zone from chemistry to microbiology. And that's your nutrients, it's your organic carbon, it's your aerobic versus anaerobic environment that then leads to the bacteria. And I start out with kind of the knowns, the heterotropic plate count and the ATP for population as an umbrella, and then dive into biodiversity, some of the dominant species. Also, an eye on the regulatory side, especially if it's a drinking water well, is coliforms positive or negative, and if they are there, are they fecal related, or what's the count? And then talk about what we saw, from a physical standpoint on the microscopic evaluation. We got bug parts, we got nematodes, we have, fine silica and feldspars present, and so forth. And then, put that into context. We see sulfate reducing bacteria, and they can generate hydrogen sulfide, which causes a rotten egg odor, which also impacts our pH. And throughout the whole report, is it a scale forming environment? Is it corrosive? Is the biology good, bad, ugly? Is it influencing the buildup or the core chemistry? And then on the physical side, all that with how is that fouling the well? And fouling is very subjective to the individual. You could have two people from the same company, and it's going to mean something different to each of them. It could be an aesthetic issue. The taste, odor, discoloration is not palatable. It could be a regulatory standpoint. It's not passing. We can't use our normal water treatment process. It could be a management issue. It's causing corrosion of the pipes downstream. And it could be an operational side. We've got an inefficient well. We've burned out the pump, the motor for the pump, or we can't leave it offline or we can't leave it online because of these issues. And so, try and interpret those results with respect to what we know as far as a complaint, and then what trends we've seen. For example, they may not realize that they have iron bacteria. But realizing that that's going to mobilize iron, that's going to impact your water treatment process. It's going to cause some premature pump failure or a need for maintenance. It's also going to impact your operational costs for that well, and so forth. And then, if warranted, if we find something, or if the client is preparing to do maintenance, then we'll advise on what type of maintenance is recommended. Sometimes, and just happened on a report I completed this morning, we have to say we're going to need some more site-specific evaluations. Video survey being much more economical and tells us so much more of what really is going on out of site, and marries nicely with our data. Might be that we need a site visit or an evaluation of stray current at the site. Do we have suspicions of flood damage or animals burrowing into? So our recommendations, span across the board. Could be something simple as pump the well, which is, kind of what I talked about earlier. An idle well is a problem across the board: chemical, biological, mechanical. So might be something as simple as pump the well or plan a disinfection. More often than not, though, people don't come to us because things are slightly off. There's an issue. Efficiencies in the toilet, production is 70% loss, or rotten egg odor, or something's not palatable one way, shape, or form. So we'll look at rehabilitation, and again, because we're usually at the extremes of things, it's a full on pull the pump, get some mechanical cleaning in there, utilize some chemistries with the mechanical, and then full evacuation on each of the steps, and then a disinfection.
Interesting. Okay. So kind of diving into some of the other things you alluded to earlier, like the bacteria having, or the biomass or bacteria, I guess we can just call it bacteria right now, is that affects more than just the slime you see with an iron related bacteria. Is so how much of things like carbonate scale and the iron and manganese nodules you see in well videos, how much of that is actually biogenic in origin as opposed to just precipitation from, and can you tell, how do you do that?
Good question. So the American Waterworks Association estimated, and I think this is in 2002, that 80% of well fouling was biologically related. And again, that goes back to what you define as well fouling. So there's some different layers of that onion to peel back. But I would say the answer is a lot more than people realize. You've got customers that have seen iron bacteria, and so they can identify that. And then, the biological concern with regards to coliforms. So, that's, and also if you've been around a well long enough, you've seen one that's slimed over. And, it's not just artesian wells or shallow wells. All wells have a slime. It just depends on what level we've reached. But the biology is playing a role somewhere in there. So for calcium carbonate scale, for iron scale, for manganese, for calcium sulfate, those are hard mineral assemblages that we can see, we can understand that, that's going to block flow within my screen. That's going to gum up my filter pack by agglomerating the grains, or it's going to be a nodule that's going to break loose and on the side of the casing and influence my water quality. At some point, biology is at play there. So, for the barnacle, it could be that iron bacteria have secreted an acid and pitted that spot and compromised that metal, which occurs even with stainless steel, kind of our Cadillac material there. On the calcium carbonate side, it could be that thin biofilm, which is a biomat or a polysaccharide exopolymer, it's a thin layer of slime, is a great point of adhesion as that mineral scale is precipitating out of solution. and it gums up there. And that's a perfect building block for the rest of the scale to build on. Even sediment, fine silts and clays that migrate in alluvial wells over time through normal operation can become entrained in the biomass. And so a little problem now compounds itself over time. Now, the thickness of that biomass is going to be dependent upon the species present, what type of nutrients are present, what type of flow is occurring in that well. So, for example, when a well is actively pumping, your biomass is typically somewhat recessed and thinner because your nutrients are coming in, your oxygen is coming into the well. You cut back that or turn the well off, even if it's overnight, that biomass is going to expand searching for nutrients. And some of the bacteria within that biomass are going to exit and try and scavenge available nutrients. Well, they may go back to the same biofilm. That biofilm may recess a little bit, but you're never going to go back to zero. And by some species leaving that biofilm, you're going to start to see additional colonies develop within the well system. And then, like I mentioned, might be the different types of bacteria. So you've got a Pseudomonas or a Bacillus, which are two species that are prolific across the known world, from the bottom of the Marianas Trench to Challenger Deep to the top of Mount Everest. You'll find them. They produce upwards of 1,000 times their own cell mass in this slime. When you jump over to an Achromobacter, very little. But then you throw in stimulation and nutrients, that little slime producing bacteria may be able to expand its population size through cell division a little faster. Or if we have limited nutrients coming in from the aquifer, that Bacillus or Pseudomonas may not go to its extremes just because it's not capable. It's held in check by the nutrients or the operation of the well, or so forth. So, their biology is always going to play a role. And as such, we always need to keep that in mind when we go to rehabilitate. It might be that, we'll just disinfect. And disinfection, it's, for the history of well owners, it's probably been the most used method of treatment for two reasons. One, chlorine is readily available, that being the most common disinfectant used, and it's cheap. So as a friend of mine says, glug glug from the jug, and a little's good. At this cost, a lot's got to be better, right? And so, we have
run down to Walmart and buy some bleach and dump it down the well. Yeah.
Why not get a case?
Yeah, that's right.
And so we go in there and, we'll get a little oxidation occurs. We'll see some iron come up. We'll knock back the bacteria, kind of like, knocking back a weed. And, it must have worked. And, a month later, 2 months later, we're right back in the same boat. And, so biology has got to be incorporated in. If we've got the mineral scale, we're going to generally need a mineral acid to break that down. But we got to remember that, that biology is there, and we don't want to incorporate the chlorine with the acid because then we'll off gas and probably lose everybody at the well site. So we need to look at an acid enhancer to target the bacteria. But then we've got to, realize, kind of like we talked about, we're not going to sterilize. So we want to disinfect, at the end, as both as, kind of a chance to reduce the populations, but then also, from a prophylactic measure, trying to reach out a little further and reduce that population. So we're going to get a longer lifespan out of that cleaning. Kind of jumbled a few things together there. Sorry, Tom.
No, that's okay. And I think that, your point on the chlorine is absolutely correct. It's probably the least effective method for actually doing well rehabilitation if you have established biomass. It's good for keeping, once you've got the well rehab, then kind of keeping things knocked back. But as far as you got to use the chemistry and usually, the biomass is going to be an organic acid, and you go after the scale with a mineral acid. So that's really, what I call the alchemy of well rehabilitation. So we got a question here. So let me kind of. Rob Gavin says, "Hey Mike, what preventative testing do you see would be beneficial to be done at the test well phase to avoid future issues?"
Oh, that's a loaded question, Rob. And I say that because oftentimes the test wells aren't fully developed, and so we can get some skewed results there. But I would say at the end of pump testing the test well, so you got an idea of what your production capabilities are. I would look at the corrosion potential of the water, so the components necessary to run a Langelier or a Reisner stability index, your conductivity, pH, calcium, alkalinity. So that'll give you a guide there for material selection. Look at some of the core nutrients. And also some of those are water quality issues too. So nitrates, iron, manganese, total organic carbon. That's going to tell me, are we going to be attracting iron bacteria? Are we going to have a nutrient source for our resident population? And then I would run ATP. So the adenosine triphosphate test is a medical test that has come into the water industry. You see it much more on the finished water side of things, much more employed there. Very few of us use it in the groundwater side, but that is a total snapshot of the population. So you get your aerobic, your anaerobic, your gram negative, your gram positive, a total count, and it's not growth dependent. So it doesn't react to the wrong blood auger or nutrient media there. And that will just give you an idea. Now, let's say with a test well, we have 80,000 cells per milliliter. That's not a high number. We've seen some wells where the counts were knocking on the door of 1 billion, but it is on the higher range of a normal operating potable well. That shouldn't rule out the well, but what it would tell me is we've got the potential for biofouling. So kind of what we just talked about, Tom, this well is probably going to have to be chlorinated regularly, just as a maintenance. Doesn't have to go in at 1,000 parts per million. If we do proactive manner, we can get away with 100 parts per million. But it does tell me, we need to have the well house accessible for cleaning applications. We will need to monitor, and maybe that monitoring is just once a year for starters. But the well owner would have to be kind of advised of that. Now, some of the additional testing wouldn't hurt to rule out iron bacteria, but typically we kind of know its potential within a region, within an area there. And because of the nature of test wells and stuff, we may not see that attractiveness so that it's showing up on the tests early on. Iron bacteria, and just kind of to explain that, sorry to get off on a little segue there, but they're naturally occurring, and they show up in a well system because we drilled a hole, threw in some generally iron structure, some heat, some agitation, and then started pumping the water to it. So we laid out the buffet and they came on down. You do see it show up occasionally in a test well sample and stuff, but just its absence doesn't mean we can throw in some low carbon steel or some galvanized metal and never worry about it. It's more of a when than if. But yeah, those would be a few that I'd start with. The corrosion, it's good for, gauging your investment and material selection early on. And then the nutrients, let you know is, do we have a resident bacterial population? Well, we know they're going to be there, but, how likely are they going to be aggravated with a well in this place? And, what's the growth potential?
To segue on something you said there, I am an advocate of people running the test, with you guys on an annual basis and tracking it in like a dashboard, a spreadsheet, graphing things out so you can see the trends over time and not just waiting till you have problems, but as a preventative measure, like you say, now we can see what's going on in our wells, what the ATP counts are, or things like that, and see how they build up over time. And we can anticipate then and start budgeting for well rehab on that basis. So I usually advise people that yeah, you got a problem now, we're going to go in and we're going to fix it and we're going to rehab. But going forward, now that you have a baseline, you got a relatively clean well. Now going forward, let's do this, the testing on an annual basis and then track those things so that we can anticipate problems ahead of time and that it's not an emergency. To get it done. You're not pumping, your well shuts down or whatever, you can see the trends. And I'm a big one on using, key performance indicators or KPIs to track the trends and using a dashboard and tracking these things. So what do you say to that? Is that a valid technique for folks?
I agree completely. And I will say that maybe it's a result of a more awareness of water being important to us as a society, or that there's fewer of us doing more of the work, but the preventative maintenance aspect is much more palatable. It's much more front and center to people in our industry than 10 years ago, and certainly more than 20. But yeah, each well is going to have its big issues, and that could be iron bacteria. It could be anaerobic growth. It could be carbonate scale formation. And so, with the full suite of analysis, like the complete profiles, what we call the 2-sample set that we talked about earlier, with that, we'll be able to identify most of the time the key issues. And so, once rehabilitation or maintenance has been conducted, a customer can come back and say, okay, I don't have to spend $2,000. I can spend $300 and just look at these key parameters in conjunction with the operational parameters, specific capacity, wire to water efficiency, and then, on the treatability side, especially for a municipality, don't disregard what the operator says. Hey, we've got shorter filter run times or higher chlorine demand or whatever it happens to be. That's got to be part of the decision process too. And those are things that my dad, Tom, and I talked about in operational stage of the well. Each well is going to have its own individual ones, but that allows us as an owner then to understand when we need to act. Think of it as the notification coming up on a more later model car that your oil's down to 10%, or you got a low front left tire. So that can tell us that we need to do something. We need to act on it in advance of that failure. And so if we can catch it early, not only do we have we can avoid that failure point, whether it's a water quality issue or an operational issue, treatment issue, what have you. But more likely, we're going to be more effective at treating it, and it's going to be less costly to treat it. So if we can catch that operational issue when we're 10, 15% loss of specific capacity, we might not have to even pull the pump. If we can catch that bacterial issue when it's just the aerobic population, we can generally just chlorinate the well. But when that aerobic then develops into a higher anaerobic and we have H2S and environmental coliforms, now we've really got to get to the bottom of that well, which translates into more time and money. That resource is offline. You're writing a bigger check. More things have to get involved to treat that problem. And, again, across the industry, groundwater, surface water, the water operators, the design elements, the contractors, there's fewer of us. And so, scheduling has been a big issue, not just because of, manufacturing delays, but, finding people when they can get out there. And then, like we talked about, bad luck and weather and so forth. So I think as an industry, we're moving more towards that proactive approach just because necessity. We have to. But also from a municipality, from a regulatory standpoint, with a heads up on those problems, we can budget it, and that's a big deal because there's tax revenue is stretched, whether it's a small municipal setting or a larger one, or even federal. If we can put that maintenance cycle into the next budget, because we identified it early, that's going to be a lot easier to deal with than having to go in with emergency funding or even to find the funds.
Or we build it into our capital improvement plan,
Exactly.
and that's because it's a little more, by using your methods, it's a little more predictive and allows us to do that budgeting so we can put it in the CIP so we have that money available when we need to. So, especially now these days when, it used to be a well was kind of designed for 40 years. Now we're asking for 75, 80 years or more. That means you really got to do the preventive maintenance and stay on top of maintaining your well because you don't want premature failure. With municipal wells running $1.5 million, $2 million or more, that's a huge capital cost, and so squeezing that extra life out of them is important. So
I agree completely. If you look in the early 1940s edition of some of the like Groundwater and Wells and Missouri Well Driller's Handbook and the Water Well Guide, good wells targeted for 25-year lifespan, a great well for 40. And, there's a lot of wells drilled in that time period that are still in active use right now. But the easy water's gone. And so, identifying what we can about the well site early with test data, like Rob mentioned, right material selection, right design, right construction and development, and then staying on top of it in a proactive manner, we can easily push, in a good setting. Because we may not get the money, we may not get that well site, we may not have the infrastructure, to find a good source in the future. So we got to do it right, but we also got to take care of it.
exactly. We're getting down towards the end here, but I got a couple more questions, and these are probably a little more esoteric, but I'll just lay them out here. One, the importance of the anaerobic bacteria in a well versus all bacteria, and two is the bacteria speciation. Some people poo-poo that, but I think it's important to understand what specific bacteria on your well. So maybe you can expound on both of those, anaerobic versus aerobic bacteria, the importance of differentiating between those two, how you do it, and then the speciation part of the bacteria again too. So
Two great questions. So your aerobic are the bacteria that thrive in an oxygenated environment, and your anaerobic are the reverse of that. They prefer an anoxic or oxygen depleted environment. Now there are what we call facultative anaerobes that go back and forth between the two environments. Unfortunately, a lot of those are coliforms, and a lot of those typically prefer the anaerobic area. Now, where it comes into play, both species are found within the well system. Both species produce slime. Both species react to their environment. So we've got some similarities there, but it's where we find them in the well that the big difference is. So generally, our anaerobic bacteria are in the lower extension of the well, and that could be a physical separation. For example, if we've got a section of blank or a sand collecting point there in the well basement. And it also can be a result of hydrologic separation. The flow moving in the upper portions or the upper screens area where we've got a, maybe 5% contribution from one zone. Also, if we've got an area that's fouled. So anything that's impacting flow, we typically have that separation between aerobic and anaerobic. Now, a lot of our problematic species are anaerobic, and I would say that is that dense biomass that you see with those species to keep the oxygen out then tends to lend itself to more advanced problems. For example, your sulfate-reducing bacteria, which can impact a rotten egg odor on the produced water. It can influence use of disinfectants, so it increases your chlorine demand. But it also impacts the pH and the corrosion of the well structure in an area where you really can't afford to have damages, the lower extension there. A lot of your coliforms are anaerobic, or as I mentioned, facultative anaerobic. And by harboring in the lower areas, generally we've got to be a little more invasive with our treatment, even if it's simple disinfection, go to great strengths to make sure that we're getting into that lower areas there. So, if I were to grab one biological test out of all ours, the one I would look at most is anaerobic. And it's a 5-tube screening sample. You inoculate it and you evaluate the samples over a 48-hour period, so 12, 24, 36, and 48. And you look at growth. Now, a strong, viable anaerobic community, which is generally about 50% or more, you will see that sample pop. It'll turn very quickly, and it's just the dynamic nature of those bacteria. A slower, stubborn, smaller population, maybe 15%. As that population increases above 20%, we start to be concerned. 25, 30, you need to start planning some maintenance. Greater than that, we're looking at generally a pretty quick turnaround and getting some maintenance enacted. So that's a great indicator. And that's one reason, we really push keeping a well active. Active well is less likely to develop higher anaerobic populations or percentages. In looking at the species, and I would say there's even biologists will sometimes, as you mentioned, they'll poo-poo or play down the need to look at them. If it's a run to failure, yeah, what's it matter? The well's a train wreck. We're going to have to drill a new one, But if you're trying to be more proactive and in a proactive manner, tailor your response to it to make sure you're addressing the problems so that you can continue to operate that well into the future. Identifying what the dominant species are is very important. Are they slime formers? Are they known to produce an almond scent? Are they an opportunistic pathogen that doesn't trip the coliform but can get a population, an immunity compromised population, sick? Are they known for pitting iron or sequestering manganese? Or, do they have a preference in one zone of the well? So, it tells us how do we respond. So if we've got, bacillus or pseudomonas, we'd certainly want to have a pre-treatment of scrubbing or swabbing and flushing that material out. We'll want to make sure that we're using a biodispersant or an organic acid in with the rest of the cleaning mixture. If it's an actinomycetes, which we know is almost like a crabgrass and prefers the borehole wall, we're certainly going to clean the inner column, but we're going to take efforts to reach further out. So we're going to look at surfactants. We're going to use a larger treatment volume so that we flood that borehole interface and that filter pack. And then we're going to look at methods to employ greater energy out, like a bore blast or a nitrogen injection there. If it's Crinithrex, that may explain why we have a manganese issue that we didn't have before. And that's test well data can say, hey, we don't have a manganese problem. We don't have an iron problem. We don't have an arsenic or a nitrate issue. You run that well. You may see biology mobilizing one of those or helping to concentrate one of those problems that turns into a regulatory concern or a treatment concern for that well system. So, if you want to run to failure, you don't have to look at it. If you want to really understand the well and understand the environments that are developing within there add an eye of cleaning and treating them and running that well into the future, knowing the species can be a very valuable tool.
All right. We had kind of wrapping up here. Ned Marks has, well, I guess it's probably more of a comment, but you might want to comment on the comment. So the life of the well starts with the first test hole. They can be sources and conduits and very difficult to find. I am finding the client understands, but the pushback is mostly from the contractor. So you can comment if you want, but Ned always imparts his wisdom.
Well, and he's got a lot of wisdom to impart.
Yeah.
I know some of the contractors that give him that pushback, and we all have a variety of people that we work with in the industry, and the thing, I hope that I'm always open to learning, and I think part of it is that we are going to have to move forward on is understanding that everyone in that process has got to be on board. What's our goal here? We need to make sure that that goal is there, and that we educate, and that everybody brings something to the table. Some people bring a lot more, some people don't. And Ned's right. Contractors, they're booked for the next 3 years out, and one of the things, it's like, hey, the client's willing to pay. They see the value in this. Do you want to address it now, or do you want to come back 3 times over the next 6 weeks? I've got a client and a friend, Gary Jen, and he's working on a project in Southern California where we had some suspected development issues. And he sat down with the driller or the contractor beforehand, outlining, the goals. And we had a subsequent conference call, and, that contractor came to understand what the driving concerns were and why. And the end result is that, we got the best development procedure out of him because he knew the why behind it. And, the owner had brought Gary on board for a specific reason. So, they were taking his professional knowledge and ability into play there. And Gary, went to the contractor early on in the process and got him involved. That contractor was a little more open-minded than some of them that Ned has to deal with. So that might be an ongoing challenge for us there. But yeah, when you look at the cost, and you mentioned, $1.5 million, $2 million for a new municipal well, throw in the time element on that too, not just getting the contractor out there, but working it through, the regulatory commissions and the water rights and so forth, or building infrastructure out. That's a big investment, for that community there, and getting the why out early on, and what we hope to do, and why we want to do things different, or why we want to do things status quo. Very important there, and then why do we want to take care of it? So back to both Ned and Robin, Rob's comments, let's start with a test well, get an idea of what these challenges are going to be, select the right material, select the right drilling process, hopefully select the right driller, and then go back and revisit that data. Maybe that the water's quality is so good and the materials are so right, we only have to evaluate it every couple of years. But if it's a very important source for that municipality or that well owner, they might be wanting to check that every 6 months to identify those changes. So then we can move in a correct manner, a lot more proactively, a lot more efficiently, a lot more cost effective to maintaining that resource.
So I think we've taken up enough of your time. This has been an awesome interview full of, great and actionable information. And I certainly appreciate, we could probably talk all afternoon. I got more questions, but we'll maybe have to do this again and pick up. But what I wanted to do was share your information, and about that background there. So this is how people can reach you, or that's what I pulled off your website anyway. And you have your main number, which is your consulting, and then the lab. And so I'm assuming if people want to use the process, they can get a hold of you any of these places and get the process going.
Correct. And thank you for the opportunity. I really enjoyed it. I'm passionate. I'm blessed in that I'm passionate about what I do, and I've got a great group of people that I work with, both here at Water Systems and within the industry, like yourself and Ned and Rob and Gary and Ed and others. I'm really blessed in that respect. And yeah, people can reach out. There's a submit an email request on the website and either one of those numbers. I am out of the office quite a bit, so leave a message, with your questions, and I'll try and get back to you in a prompt manner if at all possible. And more than happy to help. If people have some lab data, if they've got some questions they just want to talk through, be more than happy to share what I can. Both myself and my team, we've published a lot of articles in the Waterwell Journal and in AWWA OpFlow and in a variety of state and regional publications, and they're based on phenomena that we see. And so, more than happy to share those to help people solve the problems and get their resource headed in the right direction when we can.
And your book, Operational Stage of the Well, that you wrote with Tom Hanna and your dad, great source of info. I mean, there's no fluff in there. It's all it's all solid information. So highly recommend it.
Thank you.
The cost per word is
we
really
joke
worth
about it being the field manual.
Yeah, it is. It is. I use it a lot.
I appreciate that.
Yeah. All right, Mike. Thanks so much. We'll let you get back to your day here because I know you probably have all kinds of stuff to do, but this has been a great interview and I really appreciate your time.
Thank you, Tom. Thank you for the opportunity and thank you for what you're doing in the industry as well. Look forward to coming on again.
All right. We'll be talking. Thanks, Mike. Bye now. All right. That was a great interview. Ran a little longer, but boy, there's so much information there. I wanted to, show you again his book, Operational Stage of the Well. There is just a ton of information in here. It avoids all the fluff and you can get that from the National Groundwater Association. We do this show every week, every Thursday at 11 a.m. Central. So we will be, next week is 4th of July. So we'll see what we can do next week. But we're usually here every Thursday, 11 a.m. Central. Thank you very much for listening. Bye now.